next topic is capacitance parameter. Capacitance parameter. Capacitance is the property. Capacitance is the property of an element. Capacitance is the property of an element which opposes the change in charge or voltage, which opposes. So here capacitance is the property of element which opposes the change in charge or voltage. So here the charge in a capacitance is directly proportional, Q is directly proportional to V. To remove this proportionality constant, Q is equal to CV. Here where my Q is charge, V is voltage, and C is capacitance. My C is capacitance. So here capacitance is the property of element which opposes the change in charge or voltage. Q is directly proportional to V, or charge is directly proportional to the voltage. To remove this proportionality constant, Q is equal to CV, where Q is the charge, V is the voltage, and C is the capacitance. Now, if I am saying the unit of capacitance, the unit of capacitance is farad. The unit of capacitance is farad, and the symbol is, so this is the symbol for the capacitance. Here the two lines should be parallel to each other and they should have the same length. Why? Because many people they will be getting the confused. Why? Because the voltage source also will be denoted like this. This is the definite symbol for the voltage source, while we'll be having one long line and one short line, where long line is said to be the positive and short line is said to be the long line is said to be the positive and short line is said to be the negative. But whereas in case of the capacitance, the two lines should be parallel to each other. So today we'll be discussing about capacitors connected in series and parallel. So we have seen the charge in a capacitance is directly proportional to the voltage. To remove this proportionality constant, Q is equal to CV. I am differentiating both sides with respect to time. So dq by dt is equal to C dv by dt I am having. But already I know that I is equal to current is charge flowing per unit cross-sectional area per unit time. So in the place of dq by dt, I will be substituting I. So this equation can be written as I is equal to C dv by dt. This is the current expression across the capacitor. I is equal to C dv by dt. Now, when we are coming for the equivalent capacitance, so here we will be discussing about capacitors in series. Capacitors in series. I am having two capacitors. Across terminals A and B. So which is having a capacitance of C1 and this is equal to C2. Already I said current is same. So voltage across this is equal to V1. Voltage across this is equal to V2 I am having. And total voltage across the terminals is equal to V. As they are in series, I am having V is equal to V1 plus V2. But we know that the current equation in the capacitor, I is equal to C dV by dt. I am writing the same expression as I into dt is equal to C dV, or simply I am writing dV is equal to I by C into dt. I will be writing dV is equal to I by C into dt. I will be writing. Here I am integrating on both sides. When I am integrating, integration of dV is equal to 1 by C into integration of I into dt. So integration of dV is equal to V. So V is equal to 1 by C integral I into dt. This is the equation for the voltage across the capacitor. So V is equal to 1 by C integration I into dt. So in this case I can write 1 by C equivalent, or simply I by C equivalent is equal to I by C1 plus I by C2, which is I into 1 by C equivalent is equal to I into 1 by C1 plus 1 by C2. So here I will be cancelling. So simply my equation will be 1 by C equivalent is equal to 1 by C1 plus 1 by C2. This is the equivalent. This is the equivalent capacitance when two capacitors are connected in series. So 1 by C equivalent is equal to 1 by C1 plus 1 by C2. Now here we will be taking the same case as capacitors connected in parallel. So here I am taking the next case, capacitors connected in parallel. Capacitors connected in parallel. Here what I am doing, I am taking two capacitors which are having the capacitance. I am having two capacitors. Here I have taken two capacitors. This is C1, this is C2, and here my current is I. Here current is I1, here current is I2. So here as they are in parallel, can I write as I is equal to I1 plus I2. And here I know the equation for the current in the capacitance as I is equal to C dV by dt. So simply here in the place of I will be writing C equivalent into dV by dt is equal to C1 into dV by dt plus C2 into dV by dt I will be writing. So here what will happen? C equivalent into dV by dt is equal to dV by dt I am taking common C1 plus C2. So here these both will be cancelling. So C equivalent is equal to, can I write this as C1 plus C2? So here this is the equivalent capacitance when two capacitors are connected in parallel. So C equivalent is equal to C1 plus C2. So here as a summary, if I want to write the summary, so here what will happen, the summary if I am taking of capacitors connected in series, resistors connected in series and everything. So here suppose I am taking first case, I am taking resistors connected, then I will be taking inductors, then I will be taking capacitors I will be taking. So these are the three cases which I have taken. Now here in this case what I will be doing, I will be taking all the summary. So here they can be connected. This is series connection, this is parallel connection. So here what will happen, I will be writing whatever till now we have derived, I am writing in a, so whenever the resistors are connected in series, R equivalent is equal to R1 plus R2. Whenever the resistors are connected in parallel, 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Whenever the inductors are connected in series, L equivalent is equal to L1 plus L2. When they are connected in parallel, 1 by L equivalent is equal to 1 by L1 plus 1 by L2. When the capacitors are connected in series, 1 by C equivalent is equal to 1 by C1 plus 1 by C2. when they are connected in parallel, my C equivalent is equal to C1 plus C2. So this is the summary till now whatever we have derived in case of the resistors, inductors and capacitors. This is the summary what we have learned. Here we will be doing a problem on finding the equivalent capacitance between terminals A and B. So this is the circuit which he has given. I have to find the equivalent capacitance across the terminals A and B. So here, once again as previously also we have done, if they are connected in series or parallel by only current only I will be knowing. So here I will consider current I. So here what will happen? This is I1, this is I2, this is I3. Here this is I4 and this is I5. So in case of the I4 and I5, I am having 5 microfarad and 5 microfarad. So simply I can write as 5 microfarad and 5 microfarad are in parallel. 5 microfarad and 5 microfarad are in parallel. So what will happen? My C equivalent will be 5 plus 5, which is equal to 10 microfarad. My C equivalent will be 10 microfarad. So if I am reducing my circuit and if I am redrawing my circuit, I am reducing my circuit and redrawing. So what will happen? My circuit will be simply here I am having. So this 5 microfarad and microfarad, as they are connected in parallel, now the equivalent of that is nothing but simply. So here this I got as A and this is point B. This is 10 microfarad and here I am having 10 microfarad. Here I am getting this as 10 microfarad. Here I am having 5 microfarad. Now here what is happening? This 10 microfarad and this 10 microfarad are in series. So here 10 microfarad and 10 microfarad are in series. So here whenever the capacitors are connected in series, I am having 1 by C equivalent is equal to 1 by C1 plus 1 by C2. So here 1 by C equivalent is equal to 1 by 10 plus 1 by 10, which is equal to 2 by 10. But I want the value of C equivalent. So simply C equivalent is equal to 10 by 2, which is equal to 5 microfarad. So here what is happening? This 10 microfarad and this 10 microfarad, as they are connected in series, equivalent I got as 5 microfarad I got. Now what will happen? Once again my circuit will be reduced to, so here 10 microfarad as it is there, it will be there. Here I am having this as 5 microfarad and here I am having the equivalent of this 10 microfarad and this 10 microfarad which are there in series. Now it will be, this is point A, this is point B, this is 10 microfarad, this is 5 microfarad and this is 5 microfarad. Now once again when I am seeing the circuit, I came to know that this 5 microfarad and this 5 microfarad both are in parallel. So simply 5 microfarad and 5 microfarad are in parallel. They are in parallel. So simply what will happen? 1 by C equivalent is equal to 1 by C1 plus 1 by C2, which is equal to 1 by C equivalent, which is equal to 1 by 5 plus 1 by, here as they are in parallel, I am having C equivalent is equal to C1 plus C2, which is equal to 5 plus 5, which is equal to 10 microfarad. Now here what is happening? This 5 and 5 as they are connected in parallel, now the equivalent of 5 and 5 is equal to 10. Now my circuit will be redrawn as so this is A, this is B, this is 10 microfarad and this will be 10 microfarad. Now again by seeing the circuit I came to know that 10 microfarad and 10 microfarad are in parallel. They are in parallel. So what will happen? C equivalent is equal to 10 plus 10 which is equal to 20 microfarad. So here the capacitance across the terminals AB which is equal to 20 microfarads. This is the problem how we have done.